I want to take the derivative of e to the x. Now, I already know how to take the derivative of e to the x. It's e to the x, but I want to do it in such a way that shows the inverse relationship. That is, the derivative, if I know the derivative of its inverse, so maybe I already know what the derivative of the natural log of x is. It's 1 over x. I want to use this information to get this derivative. Different calculus textbooks present these things in different order. When I was learning it, I learned this derivative first, and then we came up with this one later. A lot of the textbooks nowadays do this one first and then use that to get this derivative. But the thing is, you can get one from the other. They're inverse functions of each other. E to the x and natural log x are inverse functions of each other. I ought to be able to use that to find the derivative. So what I'm going to do is I'm going to do this implicitly. That is, I'm going to first of all use that inverse function. So take the natural log of both sides, so that I just end up with an x on one side. Each time I do this, I'm starting off with an equation with y equals something, and I'm ending up with an equation x equals something. Right? So now that I've done that, I'm going to implicitly differentiate. Take the derivative of the left-hand side with respect to x. Take the derivative of the right-hand side with respect to x. I always like the right-hand side. That's easy. Derivative of x with respect to x is 1. Now I want the derivative of the natural log of y. Well, if I were taking the derivative of the natural log of y with respect to y, it would just be 1 over y. But I'm not taking it with respect to y. I'm taking it with respect to x. So the chain rule says multiply that by dy dx. Solving for dy dx now. Dy dx. And I'm going to write this a little differently than I might, just to make a point here. I have the 1 there, and I'm dividing by 1 over y. I'll pause right here to ponder the import. Actually, I don't care. I can do it there, or I can simplify this. This is just y. Ponder the import now. The derivative of the natural log of x with respect to x is 1 over x. The derivative of e to the x with respect to x is the reciprocal of that, which would just be x, but with the other variable plugged in, so it's just y. The derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in. Okay. This is, however, a completely unsatisfactory answer because I didn't start off implicitly. I started off explicitly, so I want my derivative to be a function of x, not y. So what I got to do is I've got to somehow get back to x's. Well, I happen to have a relationship here between y and x, that y is equal to e to the x, so let's plug that back in. And what did I end up with? I started off with y equals e to the x, and I ended up with that the derivative of y with respect to x is e to the x, which I already knew, but now I can see it in light of this being the derivative of an inverse function.